Welcome to the implementation of ID3 decision tree algorithm. We have a few agenda today. First, we look at the algorithm introduction. Next, we look at the first key point, finding the cutoff value of one attribute. The second key point is traversing to build the tree. And finally, we end with the evaluation. This is how we build our decision tree model. The decision tree classifies a class constructed by two inputs. The max depth is an integer that describes how many levels the tree may have. The feature names is an array of strings. Next, we look at how we fit data into our tree model. The fit function takes two inputs, attribute data and target data. Both are n-dimensional array. In the example, the attribute data is two-dimensional array of a table with 4 columns and 2 rows, and the target data is one-dimensional array of number. The prediction is done by the predict function taking one input. In the example, the input data is two-dimensional array, and the output data is one-dimensional array of number. The tree model can also print it out in a JSON format for readability. The first key point is how to define the best cutoff value of an attribute. For example, the symbol length is the attribute data, and the species is the target data. The find cutoff one attribute function takes two inputs, the attribute data and the target data. It then loops over the value in the attribute data. For every value, the predict data array is built. For example, with a value of 4.9, the predict data is true if the attribute data is smaller than 4.9, otherwise it will be false. The entropy of this split is calculated by the compute entropy split function. The final cutoff value is decided by the minimum entropy. The compute entropy split function calculates the overall entropy of the true and false cases provided previously. Let's move on to the second key point, traversing, to build a tree model. This is done in the fit function. The fit function calling itself a recursing. The best cutoff value is found for the given attribute data. The left attribute data are those less than the cutoff value. The rest is the right attribute data. These left and right data are used as inputs to fit function, again for recursing. The traversing stops when there is no more data, or all data is the same, or it reaches the max depth. The evaluation is done with the iris dataset. The experiment is run 500 times for different random seeds for the splitting. The dataset is split into 30% training and 70% evaluating. %20% noise also introduced to avoid overfitting. If we look at the outputs, the training error rate is 55% and the evaluating error is 72%. Unfortunately, these are quite high. There is a potential logical error in the function finding the cutoff value of one attribute. The best target value is decided when the entropy smallest might not be the best option. There might need to be more computation to decide what is the best target value with a given cutoff value. This is the end of the video. Thank you for listening.